Let's talk about trail slope alignment angle. This is a crucial skill for forest recreation management and making sure that the trails that you're in charge of are sustainable and that they're going to have the least impact on the wildlife species, your soil resources, the vegetation species obligated to try and survive around your trail network, and so forth. Trail slope alignment is a very simple thing in its most basic concept. What is the angle between the direction of the trail, let's say it's running this way, versus the angle of the landform? So, for those of you who've taken a geography class or a GIS class, your landform aspect, or the direction that the downhill slope is facing when viewed from overhead, that's all that is. What's the angle between these two? If we can get our trail slope alignment angle within a certain range, we can be very confident, almost regardless of other things, that our trail is going to be highly sustainable, inexpensive to manage, durable, and therefore safer for our visitors, and much, much lighter on its impacts downslope with respect to wildlife. So, let's talk about how to figure out trail slope alignment. So let's say you've got a trail running through a forest, and we're viewing it from overhead, sort of a planimetric or map view or sky view, or seeing it from space or Google Earth, something like that. Our trail is going to wind around and so forth, and it's going to be present on a landscape which is also itself winding around. So let's turn our very simple trail map here into a very simple topographic map. Let's say we've got a local peak at 1,000 meters elevation. Our trail at the nearest point to this peak is at 500 meters elevation, and then knowing the scale of the map, we can get the slope between them. Now, slope has a lot to do with trail erosion. Cliffs have pretty high erosion potential. Yeah, lots of potential energy we can convert to kinetic energy and weather coarse fragments of rock out. That's rough on a trail, and rough for everything trying to live downslope. As it gets partially buried or silted out, or if the water erodes along the trail, then the downslope sections below that start to dry out because they're getting choked off from their water supply and so forth. Alright. As you know, a topographic map uses isoelevational lines called topo lines to depict spots on the surface that are at the same elevation. So if our peak is at 1,000 meters elevation, and our topographic interval, or elevation change between lines, is 100 meters, then our first loop around the peak would be 900 meters elevation. Now this, strictly speaking, doesn't have anything directly to do with trail slope alignment angle, but it does help us understand kind of the shape of the landscape on which our imaginary little trail exists. The next one down would be, of course, 800 meters, and so forth and so on, until we get down to the elevation where our trail intersects the nearest line, at 500 meters in that case. Alright, so let's wrestle a little bit now with landform aspect. Assuming that north is up on our map, so east to the right, at 90 degrees compass direction, north at 0. South, of course, at 180 degrees, and westward equals 270 degrees. So north is also 360 degrees. This is clock math, or modulo math. When you hit 13 o'clock, you understand it's actually 1 because you subtract the maximum value of 12 from the clock face. In the same way that facing 361 degrees with your compass heading or bearing, depending on whether you're moving or stationary, 361 degrees is the same thing as 1 degree off of north in the direction of east. We go clockwise. Okay, so wherever we're standing on this hill, and wherever our trail intersects this landscape, and it's going to intersect our landscape in a bunch of spots, imagine yourself on this hill. Maybe, let's say you are right here, this little red dot. If you dropped a bowling ball safely between your feet, which way would it roll downhill? Well, it would go kind of north-ish, but also a little bit east-ish, right? If we kind of imagine our peak where it is and draw a line from that through us, then downslope is going to be kind of a northeasterly direction, or somewhere between 0 degrees straight north and somewhere below 90 degrees straight east. Now, trail slope alignment is computed for a bunch of different spots along a trail. In truth, at every inch or centimeter or millimeter along the trail, there is a trail slope alignment angle, but that's not efficient for us to calculate in the field. We can get a pretty good handle of this in a basic level with GIS and using digital elevation models and 3D surfaces and stuff like that, but those don't really capture enough detail to help us plan a trail sustainably, so this is a field skill. Imagine a bunch of spots along this trail, marked here in green as dots, where we have folks computing trail slope alignment angle. And here, where we have 500 meter elevation and the trail pretty much crossing that ISO elevation line right there, our trail is running in that northeasterly direction. So if we draw a straight line aligned with the trail right through that point where we want to measure trail slope alignment angle, then we get something like, well, it wouldn't be exactly 0, it wouldn't be exactly 90. Looks like it's a little bit more eastward than northeast, so that would be, if northeast is at 45 degrees, then a little bit past that might be 67.5 degrees. So that's east by northeast. And that equals the 45 degrees of heading northeast, plus another 22.5 degrees to get halfway between northeast and east. 22.5 is half of 45. So that would be 67.5 degrees, equaling east-northeast. Okay? So, our trail azimuth, or the direction on the compass that the trail is running, its bearing, that is, its compass facing, or its compass heading, the direction in which you're walking when you cross that particular spot, we'll call that 67.5 degrees on the compass. Our second question is, what is the angle between that 67.5 degrees, or east by northeast? What's the angle formed between our trail and our landform? At that spot on the hill where the trail is, what direction is the hill facing? Well, it looks like it's facing kind of like if we draw a line from the peak and cross the nearest topo lines perpendicularly, it's going to be something like this direction in that particular spot. Okay? Maybe a little bit more like this. Okay, so the aspect of the hill facing, the direction that the hill is facing directly downstream, or downslope, excuse me, is always exactly perpendicular to the topo line running through that spot. Whether or not there's a printed topo line, there's a topo line running through that spot. So imagine whatever line will cross the spot on the trail that you are trying to figure out, and then draw an arrow at a 90-degree angle pointing straight down slope. That will exactly be a perfect 90-degree angle versus the topo line right there. Okay, so here's our topo line, and our hill facing or aspect is orthogonal, or a right angle to that. So that looks like it is, according to our compass rose over here, just a little bit counterclockwise off of north towards west. So that's going to be something between 270 degrees and 360 degrees. So northwest is 315 degrees. So that's 270 west plus another 45, halfway back towards north. Looks like we're a little bit between north and northwest here, and really pretty close to due north, but not quite. So let's call this hill facing direction 350 degrees. So in this diagram here, it would be 350 degrees, although in our map version of it, 350 degrees points up this direction, not down like this. Don't let that throw you. Okay? So our question is, what's the angle between 67.5 and 350 degrees? Well, trail slope alignment angle is a little bit weird in the sense that it is always less than or equal to 90 degrees, and it's always greater than or equal to 0 degrees. Let's take a look at what each of those cases would look like, and then we'll get back to our little map example. Let's say we've got a peak and some topo lines around it, and this is a fairly circular prominence or mountain or hill or what have you. If we have a trail that is running straight up the slope from a parking lot nearby, running straight up the slope, it's also running straight down the slope. That'll be important later. So, our landform aspect for this is going to be whatever direction the topo line at that point on the trail crosses. And remember, landform aspects are always exactly perpendicular, and this trail is running, they're exactly perpendicular with topo lines, and this trail is running straight up and down the slope, which also makes it perpendicular to those topo lines. So the angle between the landform direction and the direction the trail is running is 0. So a 0-degree trail slope alignment angle equals the fall line, or straight down or straight up slope. That's bad. That's going to be a stream bed. It's called the fall line because that's how, precisely, waterfalls form. Streams always cross topo lines perpendicularly, just like our example trail here. Okay? At the far end, we might have a trail, let's say, that is running exactly along a topo line instead of trying to cross it perpendicularly. So this trail in this spot is running that direction, and it's also running the opposite direction, just in that one spot. Now, elsewhere the trail curves, and so it's facing another direction. But in each particular spot, it's running exactly forward and back of one direction. Okay? So this would be the azimuth, and this is the back azimuth. This is the azimuth and the back azimuth. Or this is the azimuth and this is the back azimuth. we'll see that they're kind of, even though they're 180 degrees off of each other, they're basically exactly the same thing. It just depends on which direction you're traveling on that spot along the trail. Okay? Now, here, we know that the landform facing is always exactly perpendicular to the topo line, and we're running exactly parallel to the topo line. That means we got a 90-degree angle between the trail and the direction the hill slope is facing right there. Same thing here. Landform aspect, 90 degrees, a perfect right angle off of where the trail is running in that spot. So this is an iso-elevational trail. It's running exactly along a contour line. It neither gains or loses any elevation by definition. In this case, that angle formed between the landform and the trail is 90 degrees. Perfect right angle. So instead of a fall line trail, we call this a contour trail, or a slabbing trail, because you're walking along a flat slab. Even if the area around you is not flat, you are moving in a flat way. Pretty cool. So there is no slope, no gain or loss in elevation. And since water always crosses topo lines at a 90-degree angle, in these spots along the trail that is iso-elevational, it will flow perfectly across the trail and only intersect it in that spot where they kind of lay across each other. And it will not try to flow along the trail, which would be a swampy, muddy mess, no fun, and pretty erosive, pretty rough on endemic species in the case of a trail that runs straight up the slope. So a fall line trail develops waterfalls. A contour trail drains well. Yay, that's good. But that well-drained trail won't do a good job of getting up to the exciting mountaintop up top, the top of our watershed. Uh-oh, that's a problem, isn't it? So, what we need to do is figure out how to get a trail, typically from a spot like a parking lot, an access point. They tend to be lower elevation where it's flatter, where we tend to build our roads. We would use something like switchbacks to keep the trail from being relatively steep, to keep it from being a fall line trail, which drastically increases the length of the trail you got to build and maintain, but makes it a heck of a lot more sustainable, like our contour trail over here. If you're a mountain biker and you're accessing a parking lot on the far side of this little mountain, you don't want hard turns like that. Maybe you want a series of climbing turns that look a little bit more like this, a little bit more swoopy. Horseback riders also need large radius turns, 200 feet in diameter, so they can see in front of them and behind them at all times. Switchbacks are kind of scary for horses. They are prey animals. So, the answer for a good sustainable trail that has a low maintenance alignment, like our mountain biking trail or our hiking trail with switchbacks, is going to be some optimized compromise between staying away from a fall line trail and being a contour trail as much as possible, but that also gets us up to the summit. So, what's going to happen is, with our switchback trail, this is going to have a very, very large trail slope alignment angle. At each point along our switchbacked trail, it's a lot like our contour trail, but it's just offset a little bit from the contours. So it gently climbs its way up, nice and slow. And yeah, this will be 2 or 3 times maybe the length or the amount of trail you got to build versus the fall line trail. But you can fire and forget this. you can cut it in and do light maintenance for the rest of eternity. With the fall line trail, you're going to be doing heavy maintenance, sometimes multiple times a season. That's not sustainable from a money perspective. So we want to avoid that as much as possible. With our mountain biking trail, long sections of it are going to be very sustainable, just like with the switchback trail, because they're basically following whatever contour line they happen to be at, where it looks like it's just kind of wrapping itself around the mountain. And now we do have short sections that point directly upslope and directly downslope on parts of each of these turns. But those are short sections, and maybe if we're really good at this, we can get our show in order to make sure that the trail slope alignment angle for most of it is close to 90, but not exactly 90. So we actually gain a little bit of elevation, or drop a little bit of elevation as we go, but that we have very short segments, minimally sort of stacked throughout to make sure that we are actually climbing. Eventually we get to the top. Now, if we can do a great thing like locate this climbing turn on a snowfield in an alpine area, or on rocks, like bedrock ideally, well, those are pretty durable surfaces, and it doesn't matter that we have a fall line trail right there. Those coarse fragments, those big rocks, those scree fields or talus slopes or those cobbles, they'll drain water very effectively, and that will keep these sections from getting completely ridiculous. Okay? So in this case, for the case of the mountain bike trail, we have very sustainable, high angles, large angles close to 90 degrees at most spots along the trail. And then in a few spots, we can't get away with it all the time. We're going to need to make sure that we monitor those particular spots a lot, and we use the more sustainable segments to get to those and manage those very short, typically much steeper sections as intensively as they need to be managed. Okay? So, here are a couple of good rules of thumb out of the research we've done on what makes for a good trail slope alignment angle. So without getting into all the soil physics of it, we want a couple of things to accomplish here. First, we want our trail slope alignment angle to be as close to 90 as possible, but not spending long periods of time at exactly 90 degrees. So, for TSA, for any given point on the trail, and a short trail segment, 10 meters, something like that, is kind of functionally equivalent on a map scale to a single point on the trail. So each trail segment, we want it generally, if we can, to be between 90 degrees, that is contour, iso-elevational. Want it to be close to that, or we want it to be at least, well, ideally, seven and a half degrees is going to keep us nice and chill in terms of sustainability. If we have it between 82.5 degrees angle between the direction the trail's going and the direction the landform is facing, then we're going to have, if it's between 82.5 and something like 75 degrees, so 15 degrees off of the contour line, then this is excellent up here. This is great up here. Between 75 and 60 degrees angle between the direction the hill is facing and the direction the trail is running. That's danger, Will Robinson. And it's expensive to manage. If our TSA is smaller than 60 degrees, and especially smaller than 45 degrees, like it's running closer to the fall line than it is to the contour, wow, huge problems. Major expense, and we see the risk go up. And that is something we need to pay attention to as foresters, because if we make trails that are so steep that they're unsafe, they're collecting cobbles that we're eroding out of the soil, then we're responsible for that. This is happening on our watch. This is our house. Okay? So for each of these trail segments, each of these points along a trail, you want to think about, either in a GIS map situation or out there on the trail, how's this trail running right here? Am I climbing straight up a slope? That's pretty efficient in terms of exertion, but this is a disaster for management. That's our fall line trail. Or am I circumnavigating a mountain without ever actually climbing the peak? That's super sustainable, but a lot of people typically want to visit a peak, and so circumnav trails might lead to some pretty unhappy visitors creating their own trail straight up, and now we've got an unmanaged trail doing the absolute worst case scenario. This is extra bad. Okay, so we want to factor in human motivations and needs as the sort of global super predator wildlife species, and understand that they want to have a sense that they are making good, strong advances towards their goal, the peak. A lot of folks are very much outcome-oriented when it comes to forest rec and stuff like that, so we got to balance that physical sustainability of a contour trail versus the motivated, goal-seeking behavior of humans and the fall line trail approach that they'll tend to adopt. Shortest distance between 2 points, if you can think of it that way. All right, so trail slope alignment on a hill viewed from the side. The hill slope is kind of facing towards us, coming out of the screen a little bit. And so if we have a fall line trail growing straight up, from the side it would look like this. If we have a switched back trail that starts at the same place and ends at the same place and runs through that same spot, it looks like that. And you can see there's a big angle between the fall line, the hill facing, and the direction of the trail, either direction. With the fall line trail, the angles are one and the same, okay, when viewed from overhead. This is the basic idea of trail and hill slope, or landform, the angle between them, or TSA. And now you know how to design a trail. This is the new hotness. This is old and busted.